Welcome to today's demonstration. Before we begin, we'd like to clarify that this video is not a paid or sponsored content. However, we would like to thank RISH Instruments for providing us with the RISH LM1340 multifunction meter, which we'll be showcasing in this demo. Whether you're a beginner or an expert, this video is designed to help you understand how to connect and communicate with an AC meter using a microcontroller-based control board. So, let's dive in. In a typical electric vehicle application, AC supply from the grid is converted to DC supply and fed into the EV battery. One of the most critical aspects of this process is calculating the cost of charging. This depends on several factors, including the amount of energy drawn from the grid. That's where an AC energy meter comes in. It accurately measures the energy consumption, helping us calculate costs effectively. An AC meter like the RISH LM1340 has multiple input terminals. One set is used for auxiliary input, providing power to the meter itself. Another set of terminals connects to the points where measurements are made. Multifunction meters can measure various electrical parameters simultaneously: voltage, current, active and reactive power, apparent power, frequency, power factor, total harmonic distortion, and even individual harmonics. These measurements make it an ideal choice for advanced applications. Modern digital meters provide options for data communication through protocols like UART, RS232, RS485 Modbus, USB, or Ethernet. For this demonstration, we're using RS485 Modbus to interface the AC meter with our Renesas RA4M1 microcontroller-based control board. Let's take a quick look at our setup. Our setup includes 1. The Renesas RA4M1 microcontroller-based control board. 2. Relays and switches connected to the control board for controlling power flow. 3. A TTL to RS485 converter to handle Modbus communication. 4. A dot matrix display to show real-time data. 5. A Python script running on a PC to visualize data on a dashboard. 6. Multifunction AC meter to measure single-phase AC supply. The AC meter receives auxiliary power from a standard 230-volt, 50 Hz supply. The voltage to be measured is also 230-volt, 50 Hz, connected via a relay. When we activate the toggle switch, the relay connects the measurement voltage to the meter. Our microcontroller then reads the voltage value through Modbus communication. The voltage value is displayed in real time on the dot matrix screen and simultaneously sent to the PC using UART communication. The Python code running on the PC receives this floating point value and displays it on a dashboard for easy monitoring. A key feature of this setup is the ability to disconnect the measurement voltage while keeping the AC meter active, thanks to the independent auxiliary supply. This flexibility is especially useful in industrial scenarios. And that concludes our demonstration of how to interface an AC meter with a microcontroller-based control board using Modbus communication. We hope this video has been helpful for both beginners and experts alike. We'd like to extend our heartfelt thanks to RISH Instruments for providing us with the RISH LM1340 multifunction meter, even though this content is not sponsored. Stay tuned for our upcoming videos, where we'll show you how to connect and communicate with DC meters using RS485 and Modbus protocols. Don't forget to like, share, and subscribe for more updates. Thanks for watching.